Okay, kids. Today we are going to talk about the main part of our whole urinary system, and that is our kidney. You're going to know so much about this kidney, and you're going to know so much about little tiny microscopic things in this part of the kidney pretty soon. Anyway, what does our kidney even do? The main function of our kidney is to remove waste products from our blood. It's very important. The kidneys filter about 48 gallons of water from the blood daily. What? You're probably like, I don't pee that much in a day, Miss Parker. That's because most of those 48 gallons is actually reabsorbed back into the bloodstream. Less than 1% of that, about 1.5 quarts, becomes urine. So the kidneys work kind of like when you clean out the refrigerator or the pantry. You take everything out, and then you put back in the things that you want to keep. That's kind of how the kidneys work. They take like almost all of the stuff out, and then it's like, okay, let's reabsorb selectively what we want to put back in. So they regulate the volume and the chemical makeup of the blood, which is to say they maintain the correct levels of water, salt, and pH of our blood. The kidney is also kind of magical because it can make glucose from amino acids and glycerol during prolonged fasting periods. Some of you fast, and your kidneys might be helping you out there, making glucose for you when you're fasting. It can also make some hormones. I don't even think we learned about those. These hormones that can regulate blood pressure, kidney function, and also stimulate red blood cell production. There's a hormone made by kidneys that stimulates hematopoiesis. Okay, so those are the things that the kidney does. Let's label some of these things. So obviously this big giant thing here taking up most of the picture is our kidney. The gland on top of the kidney here is the adrenal gland. You don't have to write suprarenal, it just means that's on top of the kidney. Supra, above, renal means pertaining to kidneys. So this big vessel here is our inferior vena cava. This vein that branches off of the vena cava is a renal vein. Again, renal just means pertaining to the kidneys. Here we've got some renal arteries. They do not merge with the inferior vena cava. They go kind of behind it. This tube right here is your ureter. All right, now that is that diagram. So where are our kidneys anyway? Here they are in the diagram, but they lie on either side of the vertebral column, deep in the abdominal cavity. The lateral side of the kidney, this side, is convex. The medial side is concave. You're probably familiar with those words. And the entrance to the kidney on this concave side here, where the ureter, these veins and arteries enter the kidney, is called the hilum. H-I-L-U-M-O-R-Y. The hilum. That's the entrance. It's not labeled there on that picture. That's okay. Okay. So, just some more details about the external anatomy of the kidney. Once again, we have that entrance, the renal hilum, the area where the ureter, some blood vessels, and nerves enter and leave the kidney. This hilum is near the center of the concave or medial border. you've got 3 layers of tissue that surround each kidney. The deepest layer, is the renal capsule, which is made up of dense irregular connective tissue that is continuous with the ureter, just kind of becomes the ureter. There's the adipose capsule, which is the fatty protective layer. And then there's a layer, it's kind of thin, it's called renal fascia. F-A-S-C-I-A-L-A, fascia, anchors kidney to surrounding structures and to your abdominal wall. And the typical kidney is 4 to 5 inches long. So one of those layers mentioned was the adipose capsule, fatty protective layer. And this is a very important layer. It's so important that extremely thin people with not a lot of adipose, they run the risk of something called nephroptosis, or floating kidney, in which the kidney drops and can kink the ureter, causing urine to back up in the kidney, causing kidney damage or even failure. Dang. So it's okay for one kidney to be a little lower than another one, because here, here's the ureter. It can still take urine down to the bladder. Over in this X-ray image, you can see that the ureter kind of has to go up and go back down like a kink. And so the urine doesn't flow down to the bladder, it backs up into the kidney. So that can be very dangerous. All right, let's label some parts of this kidney. Let's start with the part right here. This is called the cortex. This is this kind of outer area. It goes all the way around the kidney. But it's just this outer or superficial-esque region. That's the cortex. We're going to learn a lot about the cortex. There are little structures in the cortex that are very important. Then you've got these kind of triangular areas, these little wedges. These are called renal pyramids. And there's several of those. 1, 2, 3, 4, 5, 6, 7. There's 7 of those. You've got these renal columns that just kind of come down in between the pyramids. This right here is called the medulla. This is, it looks like it's pointing to a pyramid, but the area where all the pyramids are is called the medulla. So the medulla is the area that contains all the pyramids. Okay. This little structure at the bottom of this pyramid is called a minor calyx. It's just kind of like a little tube that's going to take some urine. And those minor calyces are going to merge into major calyces. And the area where the major calyces are is called the renal pelvis. So all of these calyces in here make up the renal pelvis. All right, this blood vessel here is a renal vein. This is called a renal artery. This tube is, you guessed it, a ureter. It's going to take all the urine down to the bladder. And I saved this one for last because it's the most important. This is a nephron. The nephron is the most important functional little unit of the kidney. This is the little guy that actually does the filtering. And we're going to learn a whole lot about nephrons in the pages to come. Okay, that is a nephron. These are microscopic and you can't see them with the naked eye, but they're there. All right, next page. So you've got the renal cortex, the outer shell around the medulla, and the cortex appears grainy, kind of, if you look at it, due to the presence of nephrons. There's a whole bunch of nephrons in a kidney. The renal medulla, if we're going to define that, it's kind of the central region, not the very central, but it's deeper to the cortex. It has all the renal pyramids. That's a terrible P. These are the triangular areas in the medulla that we just labeled. And the medulla has the renal columns. The columns are just extensions of the cortex. And they kind of separate the pyramids. Again, pause this if I'm going too fast. The renal pelvis, this is kind of like a widened upper end of the ureter. It's where 2 or 3 major calyces join together. Calyces is plural for calyx, C-A-L-Y-C-E-S, T-R-A. Oh, there it is. Calyces are extensions of the pelvis that collect urine from the medulla. Walls of the calyces and pelvis are smooth muscle, and they move urine by this cool process called peristalsis. But you know that word, peristalsis. The renal arteries and veins supply blood to the kidneys. The arteries take blood to the kidneys. The veins take blood away. The arteries are attached to the abdominal aorta, just the aorta. And the veins are going to attach to the inferior vena cava. Now, the next page is a diagram that I hope you can try to label. And I will show you the answer key, which is right up here, the next time. We're going to stop today's notes right here. Hope you guys are doing okay with all these digital learning days. I miss you. Bye.